So here's a little video on acids and bases, names and formula writing. Put this in my chemistry notebook. There'll be 4 pages on this video: naming acids, more naming of acids, writing formulas for acids, and names and formulas for bases. So first of all, when you're naming acids, to me the easiest thing to do, or the best way to start, is by just naming the acid as if it were a regular ionic compound. So HCl, hydrogen, chloride. The second one, this is hydrogen, and the ClO minus anion is the hypochlorite. And I don't know if you're familiar with that ion enough or not, but for our purposes, it'll be okay. The ClO2 minus is just the chlorite ion, so hydrogen chlorite. And HClO3, the ClO3 minus is the chlorate ion, hydrogen chlorate. And HClO4, the ClO4 is the perchlorate ion, hydrogen perchlorate. Okay, now that we've got that established, we can look at the endings on each of the anions. If the anion ends with the letters IDE, then it's going to be a hydro, whatever the base of the anion is, ic acid. So on the first one, we've got hydrogen chloride. So that will be hydrochloric acid. Hydrochloric acid. The hypochlorite, that is the ite ending, ide there, ite here. If it's ite, we change it to OUS acid. We don't have any hydro on this. It's just whatever the anion is, change the ending to OUS. So hypochlorite will become hypochlorous acid. Chlorite being the next one. Ite, it's still OUS, there's just no hypo with this one. It's just chlorous acid. The chlorate ending with the ate ending would change to ic acid, no hydro again, so hydrogen chlorate would be chloric acid. And hydrogen perchlorate, it's the perchlorate ion, ATE at the end, perchloric acid. Perchloric acid. These are your acid names, and the black letters there. Depending on your teacher, you may not want to let them see this part. I don't know how they will behave on something like that. But anyway, these are the names of the acids. Really, once you understand, it's the anion ending that matters. Let's turn the page. Here's some more. Again, this would be on the first one. If you want to pause here and do these on your own and then come back and check, you can do that. I'll give you a couple seconds while you pause. Okay, you're back from pausing. This is the hydrogen iodide. Again, the ide ending is going to be hydro iodic acid. SO4 is the sulfate ion. This is hydrogen sulfate. So it will be sulfuric acid. CN is the cyanide ion, which again, even though it's a polyatomic, it does end with ide, so hydrocyanic acid. PO3 minus 3 is the phosphite. So this will be phosphorus acid. MnO4 may be a new one to you. Permanganate. Oops. Manganate is the ion, PER. Let me clean that up a little bit. Permanganate. So it ends with H, so we'll change the 8 to ic. Permanganic acid. And that's the acetate ion. So this would be acetic acid. So, oh, I'm erasing. Sorry, I did not mean to do that. I wanted to highlight. So there are your acid names. How did that happen? There's the names of the acids. These were just the anions that we used in order to calculate those. So on to the next page, we will do writing formulas for acids. It's just the opposite. If we've got there's no hydro here, it's an ic, so that means that this is not carbonic, would have the cation, or the anion, sorry, carbonate. And carbonate ion, as you have all memorized, CO3 minus 2. We're going to have to add counterbalancing hydrogen ions. It's going to require 2, since each hydrogen ion is a +1. We're going to need 2 of those +1s, H plus, CO3 minus 2. So it's going to require 2 of these hydrogen ions to balance H2CO3 is the formula. Sulfurous acid, that will be sulfite, which you have memorized, SO3 minus 2. Again, we're going to need 2 hydrogen ions to balance that out. H2SO3 is sulfurous acid. Hydrosulfuric, hydro and ic tells me this is the sulfide ion, which is S minus 2. So it's going to require 2 H's, H2S for the formula for that. And phosphoric acid, phosphoric, no hydro, so it's just phosphate ion, PO4 minus 3. I'm going to require 3 H pluses. To make that work, so H3PO4 is the formula for phosphoric acid. Let's clean that up a bit. Okay, so again, it's just going to require some patience and some practice on your part. Now to the easy part, names and formulas of bases. There's no difference in this in just regular naming of ionic compounds. These are just metal hydroxides. So NaOH, Na is sodium, sodium hydroxide. CaOH2, calcium hydroxide. FeOH3 is going to be iron. Iron can have more than one charge. Hydroxide. Which iron is it? Is it iron 2 or is it iron 3? Well, if we remember that the hydroxide is a -1, we have 3 of those, making the right side of the formula have a charge of -3 overall. So the iron must be +3 because it has to be neutral. Iron 3 hydroxide. Lithium hydroxide. Now we're going from names to formulas. Lithium is +1, hydroxide -1, lithium hydroxide. Copper 2 has a charge of +2, each hydroxide -1. But remember, hydroxide is a polyatomic, and up here in the top, you'll notice I always put that in parentheses on the ones that were needing more than one of them. So we need 2 hydroxides, Cu, not Ca. Cu. CuOH2. Aluminum hydroxide, you'll recall aluminum has a charge of +3, hydroxides -1. We're going to need 3 hydroxides, Al, OH3. So that pretty much wraps it up for the names and formulas for acids and bases. Pretty quick tour of this, but there we have it. So hopefully this will do you some good.